Hello everybody, it's Chucky here, and today I would like to walk you through the installation of Raspberry Pi operating system on a Raspberry Pi. But the first things first, let's go through a few questions and take some decisions that may vary in between different scenarios or cases that you're gonna face with. First, 32 or 64 bits operation system. Let's have a look from the hardware point of view. All the Raspberry Pi versions listed in here are equipped with a 64-bit processor. So let's reverse the question. Why shall you use 32 bits operating system on a hardware that is already capable for a 64-bit version? The only thing to consider is that Raspberry Pi OS 64-bit version is currently under a beta release. Nevertheless, you can use either Ubuntu desktop or server version, which are already available in a 64-bit version for the Raspberry Pi. Second, version of operating system. Out of 64-bit systems currently available are Lite and full versions. As Lite states itself, it's not taking too much resources from your hardware. So the full version may not fit the older versions of Raspberry Pi like 2, 0 or 3. If we are talking about the 4 or 400, these may be equipped even with 4 or 8 gigs of RAM, so the full version should work fluently on those. Nevertheless, if you are willing to install Minecraft server, for example, or a web server with some search engine, that may be requiring a lot of memory. So even in a case of using Raspberry Pi 4 or 400, for some cases you may be still willing to use a Lite version instead of full. Talking about the versions, the difference is also in a user interface. The full version is equipped with a user interface, something similar what you may see in a Windows with a taskbar and a start menu, and full version is also equipped with some pre-installed applications, where the Lite version does not have it. The Lite version is mostly used over the terminal with a command line. If your Raspberry Pi is equipped with a screen, keyboard and mouse, you may want to go with a headful scenario, which does not require you to have any connection during the first boot. You can log into the terminal or to the operating system via user interface directly from the Pi using your screen and keyboard. The headless means that you do not need these peripherals and you will connect over the local area network, either cable or Wi-Fi. Now, running the operating system from an SD or USB card. It might depend on what you are having currently available, but from my experience, I may say that most USBs are performing better than SDs based on the benchmarks I did. If you are looking on the SD cards, please make sure it's at least A1 application performance class as proposed by Raspberry Pi, shown on the picture here, and by the class specification table, A1 at least. It's a good approach to have your Raspberry Pi connected directly with the internet. This will allow you to download whatever updates and upgrades of your software and install applications that are needed for the project. If you want to go with a headless solution, you have to have somehow connected the PC or laptop that you want to use to connect to your Raspberry Pi. So here you may decide in between a cable over a gigabit LAN port or a wireless that is also available in most of the hardwares. The difference is that wireless connection requires predefinition of the Wi-Fi credentials before the first boot in a headless solution. The cable connection may allow for predefinition of, for example, IP address, but you don't have to do it. Regardless of connection type, cable or wireless, the headless solution requires of somehow remotely control our Raspberry Pi. We may choose in between the simple terminal window with a command line or a full view of our software user interface with a taskbar and start menu and installed applications. This would be virtual network connection. This would be a terminal which requires only SSH connection. SSH might be used for both variants of the OS, Lite and full, where VNC may be used only with a full version which has the user interface. Connection over an SSH also requires pre-enabling before the first booting of the Raspberry Pi. So the case we'll walk through will be Raspberry Pi operating system 64-bit Lite. I'm going to use the Raspberry Pi that I have currently available, which is a 4B and an 8 gigs of RAM. I'm going to use a cable connection in here, so I will have to predefine as minimum SSH, pre-enable it, and I will show you how to predefine the Wi-Fi connection or configure the IP for a cable connection upfront before the first booting. We'll have to burn the operating system image into our SD or USB, and if you are having a Rufus or Balena etcher pre-installed, you may use those. I'm going to show it on a Raspberry Pi Imager, as this one allows to install many other dedicated operating systems for Raspberry Pi. So that's where we're going to go with. For a case when the connection over a cable with a static IP or wireless with a predefined credentials, we may not be having to use any network scanner. But for the case where the IP of our Raspberry Pi after first boot will be unknown, we're going to use the Angry IP scanner, which requires also Java to be installed. And finally, for the connection over SSH protocol, we're going to use a PuTTY. We'll end up with a terminal shown on our PC or laptop with a command line while updating the Raspberry Pi with the latest packages from the repositories.